welcome one and all. Thanks for being here. It's really appreciated. Our fourth session of 6, so we're kind of getting there, right? Look, we've got a really busy session, so we're going to get pretty much straight on with it.
But where do we really want to go with this? Well, this is where we bring our ruler into play. Okay, so I've got my ruler. I remember how to use this thing. How do we get the resultant forces here? And of course, the answer to that is what we looked at last time, is we use a parallelogram. Okay, so we use a parallelogram. So let me bring that into play. So what I'm going to do now, and you will literally measure this. Okay, let me draw that in first of all. So what we're going to do here is we're going to take our parallelogram, use our ruler, line it up really neatly, like this, not quite there, like that. And now what I'm going to do is I've got a resultant force, like this. Okay, so now I have my resultant force. Okay, my resultant force. So again, how would they examine it? Mark this. A predetermined circle tick 1 mark. There's going to be some reference over here. Let's say that was 0.3 on the mark scheme. Weight force is dominant. Circle tick 1 mark. Maybe that was 0.5 on this. I want to introduce you to the notion of fluid dynamics. Now, be aware that with fluids, we are talking about two things. We are talking about liquids, and we are talking about gases. Okay, so we're talking about the dynamics of how things move in liquids and gases. Okay, and what of course we find is that at this point, and at sensor number 2, the air is travelling faster. Now remember, the sensor is not measuring the airspeed, the sensor is measuring the air pressure. I'm simply saying that at this point, the air is faster. Why? Because it's been squeezed through a narrow space. And of course, as the air comes back out into this opening, this other vestibule, to sensor 3, here, we've effectively got slower air. Okay, and if you remember, we also had a third force, which was L. And all I'm going to leave you with for now, because we're going to look at this right at the start of the next session, all I'm going to leave you with for now is that this idea and this L is achieved because of exactly this Bernoulli principle, exactly this reason.
So, Lindsay Taverner, could you please repeat the explanation of why the lift acts upwards in the paper, e.g. Yeah, okay, let me do that again, Lindsay. Okay, so when I blow across this in a moment, my breath, beautiful and rose scented, obviously, not like a guy who's had 6 cups of coffee and worked too hard in a day and is still working that. What's happening is that air is moving fast across the upper surface of the paper. So above the paper, the air is going to be moving fast. Below the paper, the air is going to be stationary. So the fast moving air above is going to be low pressure. The stationary air underneath is going to have higher pressure. So there's going to be high pressure here, low pressure here, and it's going to lift that paper up. So if I try that again, let me just move this other way. This show will go automatically into the on-demand course. It should be in there about middle of tomorrow by the time we get it in there. So yeah, lovely. Happy to be here, and yeah, all the best. See you soon, folks. Take care.
Have a good evening. Bye.
Cheers, guys.